All right, Math 1. We're taking a look at these notes, 2.5 Systems of Equations and Graphing. And we're going to start off by having you guys deal with a question, okay? And so you're going to get the most out of it if you actually attempt to do this instead of just sitting there doing nothing, okay? So put some effort in and let's try to get this done. And there'll be certain times I'll have the guest teacher pause the video so that you guys can have some time to work on them. So let's take a look and make sure we understand the problem, and then I'll give you some time. So Horatio has been offered a job and has decided on which payment option to take. Okay, here's the options. Option 1. His starting salary would be $50,000 with a guaranteed raise of $5,000 per year. It's not bad. Okay. Option 2. His starting salary would be $40,000 with a guaranteed raise of 10% per year. Okay. So those are the two options he has to choose from. And so the questions we want to understand to help us, let's say Horatio's your friend and he's asking you what he should do, which option would be best, okay? So we've got some questions to consider. So the first question, after how many years would it take for the options to be the same? Or I guess, are they ever the same? Okay, if he's only working here for 5 years, which would you take? If he's working here for the rest of his life, he knows this is his only job he wants, okay, which option? And then what would we advise him to take? Okay, so first thing you need to do is understand what it's going to be like dealing with these guys, okay? Let's take a look at this visually. So what I want you guys to do is take in this information, okay, option 1 and option 2. I want you to fill out the tables, and I want you to graph it, okay? Now this X is basically our years, okay? So at 0 years working there, 1 year, 2 year, 3 year, 4 year, and so on, okay? So if we could pause for a little bit, let's give ourselves, let's try to see if we can, how much we can get done in 5 minutes. So in your groups, we want to fill out the table at the very least, okay, in 5 minutes. Maybe we'll get you graphing, but let's at least get the table. Okay, you got 5 minutes, so if you could pause the video. Okay, so you should have gotten your table filled out. Okay, now option 1, we're starting at 50,000, so this would be 50,000. Okay, and it's growing by a rate of 5,000 per year. So at year 1, we'd have 55,000. Then year 2, 60,000 we're earning, or Horatio's earning, I guess, not us. Then 65, then 70, 75, 80, 85, 90, 95, 100,000 after 10 years. Okay. All right, so that's option 1. Okay, if we were to make an equation for option 1, right, it would look like this. Well, we'd go y equals, or f of x equals, our starting number, 50,000, and we're adding 5,000 every year. Okay? All right, let's take a look at option 2 now. So option 2, we're starting at 40,000, so that would be 40,000. And we're guaranteed a raise of 10% per year. Okay, so if I went 40,000 times 0.10 for 10%, we'd see that we got a raise of 4,000. Now many of you would say, well, option 1 obviously is the best deal, but you got to remember, you take this and you add it to that. Okay, but then that new number you're going to times by 10%. So the next year, you're actually earning 4,400 or 4,400. Okay, and so it would be 48,400. All right, so essentially what we've got going here is that we're increasing by 10% each year. Now, the way to think about it, because there's an easier way than having to take all of these and times it by 0.10 and then add it, okay? And the way to think about it is like this, okay? So we're multiplying by 10%, all right? This 40,000, that's 100% of our salary to begin with, okay? And what are we raising that? What are we adding to that? Well, we're adding that 10%. So overall, we're bumping up by 110%. So if I take this and times it by 1.1, we'll get our next answer. So we can use that to multiply by 1.1 each time. Okay? So if we do that, then we get 53,240. And that was a really big comma. Okay? Then 58,564. And let's not worry about the decimals. So 64,420, and it would have a decimal of 0.4, but we won't worry about that. Okay, then 70,948, then 77,900. Oh, hold on. After 64,420, we have 70,862. Then 77,948. Then 85,743. Then 94,317. And then 103,749. Okay. All right. Okay. So now we need to make sure we're graphing this. So let's give ourselves another few minutes if you haven't graphed yet to graph these. Now, we're dealing with really big numbers, aren't we? Okay. When we get up to, at least over 100,000. So what I would suggest is maybe let's make this right here 100,000. Okay, and let's talk in terms of thousands. So let's just make that 100. Okay, actually make the top one 100,000. So this one right here would be 50,000. Okay. So basically you would go like this. You'd be going up every 2, so you'd be going up by 5,000 each time. Okay? So 55, 60, 65, 70, 75, 80, 85, 90. Okay? Then here we can just go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so take a few minutes and graph this if you haven't done that already. So if you could pause the video, please. All right, so you should have graphed it, and it should look something like this. We'll start with option 1, which is blue. Oh, we forgot to mention what our option 2 graph would look like, didn't we? It would be y equals 40,000. And then since we're times them by 110%, it would be times by 1.1 to the x. Okay? And what you should have noticed, okay, we've got a linear function here, and we've got an exponential function here. Okay? So we're dealing with two different types of functions, so let's see what happens. Alright, so option 1 starts at 50,000, then 55, then 60, 65, 70, 75. So it made it easy to graph that one, huh? Okay. And you can draw the line or leave it discrete. I guess technically it would depend on how the raise happens, if it's constantly happening or if it just happens at the end of the year, which most likely would be the case, so it would be discrete. So we'll leave it dotted. But if you drew the line, don't worry about it. Okay, option 2, we start at 40,000. And then we go up to 44, then 48, then 53, then 58, then 64, and it's looking, I know we said it's exponential, but it's looking linear, isn't it? That's probably because it's got a pretty slow growth. 10% is not a whole lot. Then about 70, then 77, then 85, then 94, then 103. Okay, so we can kind of see it's got some curvature going to it. Okay, you can follow it's going, curving up like that. Okay. All right, so now looking at that, can we figure out about how many years would the options be the same? Okay. So, take a minute or two and answer that. Pause it if you need to, if you need some more time. What we should notice is, and maybe it would be helpful to actually draw the lines this time to help us visualize that. Okay, so we can see right about here, right? They're nearly the same. Okay, 95,000, 94,317. So it's going to be a little past 9 years where it would happen, right? So after how many years? We'll say about 9 years. Okay. Now, I want you to answer the next 3 questions. So take another 5 minutes, pause the video, and answer these 3 questions. All right. So, the first question, if he's only going to work here for 5 years, we'll take a look at 5 years. Look at 5 years. Which would be a better option to take? Well, obviously it would be option 1, right? So, now if he plans on working here for the rest of his life, we should notice that after year 10, okay, the option 2 is always going to be higher. See how it's growing? It's going to keep growing this way, whereas the linear will keep growing that way. So option 2 would be the better one. So which option would you advise him to take? Okay, and that one's up to you. And decide, tell me why you would think one would be better than the other. And this page I'm going to have you guys keep, and so tomorrow we can talk about, when I'm here in class, we can talk about which option you guys decided on your own would be the best one to go. Okay, so there's our system of equations. Okay, now I wanted to just show you guys one thing. I graphed it on Desmos, and we can get an exact time when they would be exactly the same. So if we take a look at this graph, which looks pretty close to the one we got, right? And we see that curvature. So if we plotted those points exactly at 9 years and 0.168 years, so that'd be like, I don't know, a month maybe. That's the amount that he would be earning, ideally, and that would be, the time when it didn't matter. So if he was staying there about 9 years, it wouldn't necessarily matter because he'd be making the same. Though technically you would have been making more these other years, so it probably would have been a good idea to still go with option 1 up to the 9 years. Okay. So a system of equations. Okay. We take more than one situation, and we're going to figure out where they meet, where they're the same. Okay, so on this back side we've got some notes. So there's some things I want you to kind of underline with me. Then we're going to take a look at some examples, and then the next day we're going to have a day of practicing, so we can kind of practice this stuff up. Okay. All right. So we graph more than one equation on the same coordinate plane. Okay. So we can kind of visualize what's happening. Now, as we saw, a table of values can help us understand pretty well what's going on as well. Okay, though, depending, it could take some more time. Okay, so here's now this part is really what I wanted to focus on. Okay, because when you're dealing with 2 or more lines, you run into different solutions. Okay? If two lines intersect, like ours did, okay, they're going to have one solution. Okay? So there's one point where those equations are the same. Okay? Now, there are situations where we have parallel lines. Okay? And parallel lines we know never intersect. So this is the case when there's no solutions. Okay? Then you also run into some rare cases where the lines you have are exactly the same. Okay? That would be like if we had 2y equals 3x, actually, 6x plus 2, and y equals 3x plus 1. Okay? They're the same graph even though they don't look like it. So they'd be the same line, so they have infinitely many solutions. Every point on that line is a solution to both of them. So if you have a solution, we use this word consistent. If there's no solution, it's inconsistent. If there's only one time when they meet, it's independent. If they're meeting all the time, they're the same thing. They're dependent on each other kind of idea. Okay? But the three things we need to really pay attention to are the one solution, no solution, infinitely many solutions. Okay? So, let's take a look at doing this. Now, we've dealt with some graphing, inequalities and equations. So we're going to basically graph and find out where they meet. Alright, so let's take a look at number one. So first thing we do is we graph both lines. So they're both in slope-intercept form, which is great. So we start out at 7 on this one. And my slope is negative 5 over 3. So I'm going to go down 5 to the right 3. So my next point is right there. Then down 5 to the right 3. Okay. And I'm going to draw my line as best I can. There's my first line. Okay, then I graph my second line. It starts at negative 2. Has a slope of 4 over 3. So we're going to go up 4 to the right 3. Okay. Then we look, where do they intersect? Well, that's pretty easy to see. It's that point right there, which would be 3, 2. So my answer is 3, 2. So there's one solution, so it's that consistent independent. Okay, we don't really have to write that, but just so you remember one solution, it's consistent and independent. Okay? Alright, so let's take a look now at number 2. So same idea. We start by graphing. So I've got negative 8, so I go down to negative 8 is my y-intercept. My slope is negative 5 over 2. Normally I go down 5 into the right 2, but I'm going to run out of space, aren't I? So we can also go up and to the left, do that exact opposite thing. Okay? So I go up 5, to the left 2. And usually I want to do as many points as I can. Okay, so there would be my line. Okay, then we graph the second one. Positive 9. We're going down 5 to the right 2 again. What we should notice here is that we actually have the same slope, didn't we? Well, that means we have parallel lines. Okay? Parallel lines never intersect, so there's no solution. So it's inconsistent. Okay? Sometimes that happens. Alright, so now take 2 or 3 minutes. I want you guys to try number 3 on your own. So, if we could get a pause on the video for about 3, maybe 5 minutes at max. Let's say 5 minutes. 3 on your own. Go. Alright, you should have tried that one, so let's take a look and see how you did. So we'd go positive 2 for our y-intercept, slope of negative 1/5, so down 1 to the right 5. Put a point right here, down 1 to the right 5, and here. Or up 1 to the left 5. Okay, and that would be our line. Then we start at negative 5 on our second one, and we're going down 8 and to the right 5. This would be like clear down here somewhere. Or up 8 to the left 5, and we can see right where that point is. Okay, so right there we have one solution, so it's a consistent independent, and our solution's at negative 5, positive 3. Alright, so hopefully that's what you came up with. Alright, now looking at number 4, now it's not in that slope-intercept form, right? So we've got to do a little bit of work to start us off. So we take this first one, so 3x plus 5y equals negative 45. Okay, subtract the 3x from both sides. It can't be combined with the 45, so you get 45y equals negative 45 minus 3x. We divide everything by 5. That gives us y equals negative 45 divided by 5 is negative 9 minus 3/5 x. So I start out at negative 9, and then it's negative 3 over 5, so I'm going down and to the right, or left and up. So I can go left or up 3 to the left 5. And I would have my line right there. Okay, then I do the same thing to this one. So x minus 5y equals 25. Okay, so subtract an x. Get negative 5y equals 25 minus x. Divide by negative 5. That'd be like a 1 there. So I'd get y equals negative 5 plus, because negative over negative is positive, 1/5 x. So I start at negative 5, and I'm going up 1 to the right 5, or down 1 to the left 5. And I can see where they intersect. And it's right here, and that's a negative 5. So it's a consistent, independent, negative 6. Negative 5, negative 6 is my answer. Okay? So those ones take a little bit more trouble because you have to rearrange your equation to make it easier to graph. Okay? Alright, let's take a look at some more. Okay, if we look at number 5, okay, again, we'd subtract a 6x, we'd have negative y equals 1 minus 6x, divide by a negative 1, get y equals negative 1 plus 6x. Okay, if we do our second equation, we'd subtract a 6x again, so we'd get negative y equals negative 9 minus 6x, divide by negative 1. We get y equals positive 9 plus 6x. Now, notice my slopes are the same. My y-intercepts are different. I don't need to graph that. Those are going to be parallel lines. So there's no solution. They're inconsistent. Okay? Okay, if I did graph it, right, it would be negative 1. Then you'd go up 6 to the right 1, or down 6 to the left 1. And that would be our first one. Then the second one would start at positive 9, and same thing, up 6 to the right 1, or down 6 to the left 1. And it would just keep going down, and they would have looked like that. Okay, number 6. Take 5 minutes. You guys try this one on your own. Alright. So you should have come up with, subtract a 3x to get 6y equals 12 minus 3x. Divide by 6. We'd get y equals 12 divided by 6 is 2, minus 3 over 6 is 1/2 x. Okay? Now, if you graphed this, you'd start at 2, go down 1 to the right 2, down 1 to the right 2, right? And draw your graph. Then if you graph this one, you start at 2, slope of down 1 to the right 2, and what do we see? Oh, this is the same exact line, which if you should have noticed right here when you solved for your y-intercept, that this and this are the same thing, which means you have infinitely many solutions. Okay, so there's solutions, so it's consistent, but there's it's dependent, right? Not independent. That's what I was looking for. Okay, so every point here is an answer. All right. Now 7, 8, and 8 are kind of like our problem we did to begin with. Okay, because we've got a linear and we've got an exponential. A linear and an exponential. So linear we treat exactly the same. So I'd start at 5. 21 over 6, so I go up 21. Wow, that's going to be a tough one to graph, isn't it? Let's see, I think we can simplify that. Can't we divide those both by 3? And that would be 7 over 1. So 7 over 1. 7 over 1, it would look something like that. Okay, then remember for exponential, this first number is our y-intercept, so at 3. And then we're doubling, so as I go to the right, I go up to 6. As I go right 1, then I go up to 12. As I go to the right 1, I go up to 24. Yeah, I'll clear up here. As I go to the left 1, I cut it in half. I do the opposite, so I'd go down to 1.5. And then even smaller, and we have that asymptote. So it looks like it would go something like that. Okay, so what we can see is that right here the y-intercepts are not the same. Why did I start where I did? Hold on. I should have started at 5, but I didn't start the other one at the right one. Hold on. Now, when you're dealing with exponentials too, you don't have those same rules as we did with the other ones. Okay. So if we look at number 8, so we can see that it's going to cross twice. There's going to be 2 solutions. And this is where technology is very helpful, okay? Because we can see that at 212 and at negative 1, 1.5, we're going to have 2 solutions, okay? Which I know on our notes we didn't have that option, did we? Okay, because this is just for 2 linears. But if we have a linear and exponential, we can have more options, okay? Alright, let's look at the last ones. So we'll start at negative 3. We go up 1 to the right 4. So it would look like that. And then we start at 2 and we're times them by 4, so that would be 8. So it would look something like this. Okay. Now this one's pretty easy. There's no solution. Okay, they're never going to meet. So sometimes you have that situation as well. Alright, so that's pretty much it, guys. No homework today. Tomorrow I'll be back, and we'll take a look at some more stuff, okay? So, there we go.